Okay, so welcome to lesson 6 of learning to program computers with Scratch. Okay, we are recording today's lesson, so we'll put it up on YouTube so Des can watch it later in the week. Alright, so today's agenda, we're going to start off by exploring message broadcasting and receiving, okay, which is a way for sprites to communicate with each other. Okay, messaging is actually a concept which is used in most computer languages. So in Windows, for example, it has a whole messaging system, and it puts messages onto it, and those messages get picked up by various programs and they do things. Okay, so for instance, when you click your minimize button on a window in Windows and it minimizes down to the toolbar, then it obviously has to change the way the icon looks on the toolbar. But that is the interaction between your application that you're minimizing and the underlying operating system. But they both use a messaging system to communicate with each other. Then we're going to have a look at creating custom blocks with custom parameters. This is typically called a procedure in other programming languages, and it's a way to let you create little pieces of code which you can reuse. Okay, and then we're going to explore top-down design and bottom-up design by writing a program to draw a house and a flower respectively. We might not get through all of this in the hour and a half, but we'll try and get as far as we can. So coming back to the messaging element that we're going to start off with, those are obviously satellite dishes. Do you have any idea what that is? This area over here. Yep, that is the Mnet or multi-choice building in Randburg. Okay, so when you are broadcasting, you need someone who's doing the broadcasting and someone who's doing the receiving. So for instance, here we've got multi-choice in Randburg with a whole bunch of big satellite dishes. They broadcast a signal up to the satellites. Those satellites bounce them back down and they get picked up by the Mnet customers or DSTV customers using their little satellite dishes. Okay, in this case it's one-way broadcasting, which is the same as we're going to have in Scratch. Okay, and let's get started with that. Okay, so there are 3 blocks which come into play when we do our broadcasting. The first 2 are the broadcast blocks. So we've got a broadcast and a message, and we've got a broadcast message and wait. Okay, now the reason we have a message here is because we might want to broadcast different kinds of things. So you might want to broadcast everyone must jump, or everyone must sleep, or change all the blue blocks to red blocks, and you will have all these other sprites listening for these messages, and then they will act on those messages. So the sending side is handled by these 2 broadcasting blocks, the only difference being that the second one has a wait component, which we've seen in other blocks before. Now the reason we want to wait is to make sure that whoever is receiving our message does whatever they need to do before we continue with our code. Alright, this sort of talks to a thing in computer programming which we call synchronous and asynchronous. Asynchronous is when you send off a message and then you carry on, and whatever receives that message does its thing and come back to you. It's not related to what you are doing. Whereas with synchronous message, you want to send a message, get the other party to do whatever it needs to do. When they're done, they hand control back to you. Alright, so we could call this one, the first one, as the asynchronous, and this one as the synchronous kind of message. On the receive side, there's only one receive block, and it is basically when I receive whatever message. Now you'll see in all 3 cases here, there's a little black triangle pointing downward, indicating that if we click on it, there'll be a list of different messages. Okay, and we'll come into an example just now why we have different messages and how that can be used. Okay, but you can think of it as the program guide on your DSTV. You've got different channels. Each message can be seen as a different channel. Okay, so here's an example. We're just going to talk through it. We're not going to actually program it. Starting off, we've got our little starfish here, and he's got a little megaphone which we're using to indicate he's broadcasting a message, and he broadcasts a message which is jump. That gets sent to all the other sprites in the program, including the starfish. That's why we've got this little arrow here. So the sender of a message can also be the receiver of a message, which can come in useful sometimes. Okay, so on our cat sprite, we've got two when I receive blocks. It's got a walk when I receive walk and when I receive jump. Okay, so the cat is listening for two different kind of messages. The frog, excuse me, also has a when I receive jump, and the bat doesn't have a when I receive jump. It only has a when I receive fly. So here you can see we've got four different sprites. One is sending a message but can also receive its own message. Two of them have a when I receive jump. One of them has no when I receive jump, and the cat also has an extra message that it's looking for. Now the second point to note is that the implementation of the jump is different for our cat and our frog. For our cat, we change our y by 60. Remember, y is our y-axis, so up and down. We wait 1 second and then we come down by 60 again. So it basically jumps up and down and comes back to the same spot. The frog changes its y by 40, waits half a second, and then changes its y by minus 50. So it lands up minus 10 lower than it did when it started. So that is how we use broadcasting. Okay, the reason it's important is we want to have a way of calling other pieces of code in our program. Alright, up till now we've been limited to the built-in what we can call events in Scratch. Here we can create different events. So for as many different things as you want to do, you can create messages. And as I said, you don't have to send messages between sprites. You can use them internally within a sprite itself. So let's go and have a look at how we create a message. So under your, I think it's control or events block, events block, you'll see near the bottom there's a broadcast and a when I receive message. And basically you drag a broadcast block onto your script area. You click on the little black triangle and you'll see at the bottom there's an option that says new message, and then you can type in a message. It can be whatever you like, but obviously choose something that is descriptive for the purpose that you're going to choose. Once you've created a new message, so on the screen you can see we created a jump message, you will see it appears in your drop down list, and it also appears in the when I receive a message block. And you can also create a message in a when I receive message block, so you can do it from either side. Okay, so we are going to do a little example now. Okay, we are going to draw a square using one sprite. So this case, we're going to have a sprite sending a message to itself. So we're going to start off with when green flag clicked, and then we're going to call the clear option, which is basically to clear whatever is on the stage. And then we are going to sorry, are you doing this on the stage? Okay, yeah. So the code here is for the stage on the left and for the sprite script on the right. Okay, remember you can drag your scripts or duplicate them. Yeah, there you go. Okay, so on the stage we're gonna, when the green flag is clicked, we're gonna clear, and then we're gonna bring in the when stage clicked event. And when the stage is clicked, we are going to broadcast a message called square. Okay, so you'll click on your little black triangle, choose new message, and type in square as the message name. Okay, so in this example, the stage is telling the sprite what to do. Okay, the reason we're using the stage is because it's a big area. If we had to click on the sprite itself, you'd always have to click on the sprite and you couldn't click just wherever you wanted to. Okay, on the sprite we have a when I receive square message. The first thing we do is we go pen up, because we are going to be drawing a square wherever you click on the stage, and if we don't lift the pen up, it's going to draw a line between the successive squares. Then we go to mouse X, mouse Y, which is where the user clicked on the stage, and then we're going to set the pen color to a random color between 1 and 200. So every time we draw a square, it's going to be a different color. Then we're going to put our pen down, so we're ready to draw our square. We're going to repeat 4 because we're drawing a square, and a square has 4 sides. And for each square, we're going to move a set size, set number of steps, 50 steps, and turn 90 degrees. Okay, and if you've got everything done, okay, you should be able to run your program and click anywhere and get it to draw a square. And every time the square should be a different side. So, as I said, in this example, you're clicking on the stage. The stage is sending a message called square to all the sprites. You've got your cat sprite, and it picks it up and draws the square of different shades. Okay. Alright, now we are going to do something a bit more advanced. This is a script that is on your flash drive. It's called flowers.sp2. It consists of 5 different sprites, and each one of them has a petal for the costume. All the petals are different. Let's go into our Scratch and load this project up. Okay, there are a number of flowers. We're just going to start with the first one. And there we go. So we have got 5 different sprites at the bottom. If we go to the costume tab, you can see each of them has a single costume, and it's different. Basically, we're going to use these to draw flowers. Okay, there is a script on the stage, which is very similar to the one we used before. So when stage clicked, we clear and we broadcast a draw and wait. So this is basically to pick a position for where our flowers are going to start drawing. If we go and have a look at the code for each of the sprites, okay, you can see the code is pretty much the same. Let's just do a cleanup here. Okay. Okay, so if we go and look at our sprites, when green flag clicked, we hide the sprites. So initially when you start the program, it hides all the sprites. Then when you receive the draw command or message, which is broadcast from the stage, we set the color effect to a random value, set the brightness to a random value, size to a random size between 80 and 100%, and then we go to minus 160 on the X value, so your horizontal coordinate, minus 160 would be near the left, and Y we pick a random value between minus 100 and plus 100. So vertically we start anywhere between minus 100 and plus 100. Then we repeat 20, so each flower is going to have 20 petals. We stamp and we turn by 18 degrees. The reason we turn by 18 is because 20 times 18 is 360, so we want to go in a full circle. If we have a look at the other sprites, you'll see they have a difference in where they start on the x-axis and how many petals they have. So the second one starts at minus 180, where the first one started at minus 160. The first one had 20 petals, the second one has 12 petals. Third one starts at 0, has 10 petals. Fourth one starts at 80, has 12 petals. And the fifth one starts at 160 and has 12 petals. So if we run our program and we click anywhere on the stage, you can see every time we click, it draws what seems like different flowers. Even though we're using the same petal, we're just using the color effects to change their colors, brightness, that kind of stuff. Alright, does that make sense? Okay, good. Now that's a lot of work because we have the same script duplicated for every petal, and we have one petal for each sprite, and we have 5 different sprites. So we are going to look at a way of making that a bit simpler. Okay, but before there we're going to talk about a few other things. The thing we're going to talk about is structured programming. Okay, up until now we have been pretty much putting all the blocks underneath one another. In some cases we have used events like when screen clicked to break it out a little bit, but it really hasn't given us a way of making things reusable. Okay, so when we do proper programming, and even in Scratch now, we're going to go through ways that we can do this. We want to break a big program up into smaller pieces. Okay, and if you think about baking a cake, that's exactly what we do. We have various steps. We go get our recipe, we find out what ingredients we need, go get our ingredients, and then we get our utensils, our bowls, our whisks, our spoons. We put the oven on, we mix our ingredients, we put it in the oven, and so on and so on. So there's a whole bunch of steps that we have to do, and we do things in small pieces. We don't just throw everything together in the bowl, shove it in the oven, and then we're done. So the main reason we like to break things down is it's easier to read, because you're only reading 5 or 10 or 20 lines instead of 200 lines. It's easier to debug. Now, have you ever come across debugging before? Do you know what the term means? What does it mean?
To find the errors.
To find the errors. Okay, do you know why it's called debugging?
I have heard of that.
Okay, so way back when, in the 50s and 40s and 60s, computers used to be massive. They used to literally be the size of a room. Okay, and the reason for that is the switching component they used in the computer at the time was called a relay, which is quite a big thing. It's most probably, back in those days, maybe the size of a box of cigarettes. And what used to happen is, obviously because the computers were big, they were quite hot, so moths like heat and warmth and light, so the moths used to fly in and get stuck in the relays. Now if a relay is a mechanical switch where it's got 2 contacts that come together under the influence of electromagnet, and if the moth got stuck in between the contacts, they couldn't close, and that would obviously cause the program not to work. So they would have to go and fish out the moth to let the relay close to get the program to work. So that's where the term debugging comes from. Alright, the third reason why we like to break things down is because it allows us to reuse stuff. Okay, just think, if you, on your example here that we just looked at, you've got pretty much the same code on every sprite. The only thing that differs is where you start and how many petals you create, but everything else is pretty much the same. So wouldn't it be great if we could just write this once and call it from each sprite? Okay, because if we don't duplicate stuff, we're also not going to make mistakes. Okay, real programmers, we like to copy stuff and paste it because we're lazy. The problem is, when you copy and paste, you end up not changing all the values you're supposed to change, and then you introduce a bug. Whereas if you just have the code once and you reuse that code all the time, if you have a bug, it'll be broken all the time or not at all, because there's only one copy of the code. Okay, and just like we said with our baking of the cake, sequence is very important. Okay, so you need to make sure you do stuff in the right order. Alright, so how do we structure a program? Okay, if you look at the left here, we have a program that draws a couple of shapes. Okay, in the beginning we do what we call initialization. Initialization is where we set things up. So we set the sprite to start off 0, 0 in the middle of the screen. We give it an initial direction, which is pointing to the right. We set the initial pen color, the pen size, we put the pen down, and then we clear whatever has been drawn before. All of this is initialization. Okay, these blocks on the right here are just what we call pseudocode, so they don't actually exist in Scratch. Okay, it's just showing you how we can break them down. We will get to creating our own blocks in a later lesson, maybe in this one even. But for the moment, don't go looking in Scratch for a block called DrawSquare. You won't find one. Okay. So we've got our initialize block. Then we go and draw a square. Simple repeat loop of 4, where we move and rotate 90 every time. So we could create a draw square block. Then we draw a triangle. Same story, repeat 3, and we rotate 120 every time. Then we turn 180 degrees, which is a simple block. You can't really simplify that. And then we do a repeat 4 again, which is drawing a square again. So all we do is we call the draw square block again. So we have taken a program which is quite long, a number of steps, and we've broken it down into something smaller. Now this code on the right here doesn't magically replace the code on the left. Inside each of these blocks you will still find the code here on the left, but it's just easier to read first of all on the right. And we've got reuse here because we do a square at the top, square at the bottom, so we have a single draw square block which will handle both of those cases. Okay, any questions? Okay. Alright, so now we're going to do our flowers again, but we are going to do it with one sprite instead of with 5 sprites. So this is on your flash drive again. We can load up flowers2.sp2. Flowers2, there we go. Alright, now if you have a look at it, okay, we still have the same code on our stage. Okay, when stage click, clear, broadcast, draw. But now we only have one sprite, but if we have a look at the costumes, it's got 5 different costumes. So we've taken all those costumes, put it into the one sprite, and if we have a look at our scripts, because we only have one sprite, we only have one set of script for that sprite. So when we click on the green flag, we hide, then we receive the draw, okay, and we've got a draw flower. So there are 2 when I receive blocks here, okay, and effectively what is happening is that the sprite is talking to itself. So when I receive draw from the stage, I set my X to -160, I switch my costume to leaf 1, which is our first leaf, then I repeat 5 times, I set my Y to pick a random between -100 and 100, which is what we did before, and then I broadcast a message called draw flower, which would go to all the other sprites, but we don't have any, but it also goes to the sprite that creates the message. So it has a when I receive draw flower block, and it goes and sets the color, brightness and size as we did before, and it repeats 15 and stamping. So the one thing we do lose here is how many petals we have. We will always only have 15 petals, where before we had anywhere between I think 6 and 12. So that's a bit of a downside, but using custom blocks, which we'll cover later on, we can overcome that. Okay. And then we jump back, so we've broadcast and wait, so we wait for the flower to finish drawing, then we change X by 80, so we move the flowers progressively from left to right by jumping 80 every time, and then we go to the next costume. So we iterate through all the petals in our sprite, and if we run this, it should do something pretty similar to what we did before. Okay, every time you click on it, it goes and draws a slightly different variation of our flowers. Okay, but can you see here, we have collapsed our petals into multiple costumes for the same sprite, and you can actually see which one it's using when the program runs, and we only have one set of code instead of one set of code for every sprite, and we are getting the stage to broadcast a draw message which the sprite picks up, and then we get the sprite to broadcast a draw flower message which it picks up itself. So we are using broadcasting here to break our program down into smaller pieces, and as you can see here, we are drawing our flower 5 times, but we don't have to repeat the code 5 times. Any questions? Nope. Okay, so that was drawing flower 2. Okay, so just to recap, if we take a trip back to our first or second lesson, we drew a square by moving 50, turning 90, moving 50, turning 90. Basically doing the same 2 steps 4 times for our 4 sides and 4 corners. Then when we learnt about repeat, this should actually be a 4, not a 10, we could simplify that by just repeating those 2 steps 4 times. Now we can go and create our own block called DrawSquare, which will encapsulate this, but when we want to use it, we just call that block. Okay, so how do we make our own blocks? Okay, good thing you asked. Okay, there is a palette at the bottom called More Blocks, and it has 2 buttons. The one is called Make a Block, and the second one is called Add an Extension. We're not going to touch on the extensions. That is for integrating to products like the Lego WeDo, and I think there's also some Arduino stuff there, but we are going to use the Make Block. So if you click on that, it's going to open up a little window, and you get to give your block a name. You can call it whatever you like, but obviously calling it something that is sensible and will make sense to you 3 weeks or 4 months down the line is a good way to go. So let's type in DrawSquare. Okay, and then we click on the OK button. Oops, should have told you to start a new project. Yeah, start a new project and do that again. Okay, more blocks, make a block, DrawSquare. Okay. Alright, now you'll see there 2 things. It creates a define block in your scripts area, okay, and then it creates a DrawSquare block in your palette area. Alright, now the purpose of these 2 is the one on the left, your DrawSquare in your palettes area, is what you're going to use in your code. The define square is where you go and say what that actually does. So if we go and draw our square now, okay, we go and under our define DrawSquare, tell it how to draw a square. Okay, so we put our pen down, obviously. Again, my mistake, this repeat should be a repeat 4, not a 10, and then we move 50 and turn 90 to get it to draw our square. Okay. Now this code on its own won't do anything until you call it, and the way you call it is by using the DrawSquare from your palette block. Okay, so to fill in the rest of the program, we can add a when green flag clicked, and we add a clear block to clear whatever is already on the stage, and then we're going to add a space key pressed. When space key pressed, every time you press the space key, it's going to draw a block or a square. So we'll pen up to make sure we don't land up with lines between all our squares. Then we're going to go to wherever the mouse is on the stage. So we're going to pick up the mouse X and mouse Y from the sensing palette, and then we're going to call our DrawSquare. We could have just as easily put the go to mouse X, Y and the pen up inside the DrawSquare, but it doesn't really matter, it achieves the same thing. And if you are getting your squares and they're a bit small, what size you did? 10 steps. Okay, if we make them 50, they should be a bit bigger. There you go. Okay, yours seem to be a bit off center. Any idea why? Because the initial direction of your cat wasn't 90 degrees. Okay, it's not a problem. I'm just mentioning it to see if you know why. There we go. That looks much better. Okay, so that is how we create our own custom block. Okay, not too difficult. Okay, so if we go back to our flower 2, so if you load it up again from file, okay, we can create a draw flower block which replaces our draw flower. So if we go to our more blocks, create a draw flower block, if I can spell, draw flower block, and then we use that. So we take away our when I receive draw flower, put our draw flower there, and take away our broadcast draw flower and put our draw flower there. Then we have exactly the same program, but all we're doing now is we are using custom blocks. Nope. You're going to replace your broadcast draw flower with your draw flower custom block. Yep. Just break off by the draw flower and put it back there. Yeah. Okay. You don't actually need those two. You can get rid of them there. Okay. There we go. So exactly the same thing, except we're now just using custom blocks to break our code out. Okay, and that is what we should have, which I think you got, eh? Okay. Alright, now, that is a bit slow. How are we going to make it go faster? I think we've already been over the turbo mode over here under edit. You can choose a turbo mode there. And if you run your program, it goes quite a bit faster. We do have another option under our custom blocks though. If you right click on your custom block in the palette and you go into edit, okay, then you'll see there's a little options thing. Click on that, and at the bottom it says run without screen refresh. Okay, if you check that, check OK, and then run your program again, it should run a lot faster. So what's happening there is it isn't trying to update the screen while you're drawing the flower. It's waiting until the flower is fully drawn, and then it basically updates the screen. So that makes them appear almost instantaneously. Okay, should we break? Would you like to take a break? Not really. Okay, alright, well let's carry on. So we've got our custom blocks now, which are very useful, but sometimes we'd like to do the same thing but in two different ways. So if we wanted to draw some squares, we don't always want to draw a square with a side length of 50. Okay, so what we would like to do is be able to say how long we would like the side length to be. So we are going to upgrade our drawing of custom blocks, and we are going to add what we call parameters to them. Okay, so what is a parameter? If I tell you to go jump, you're going to ask me how high. So how high would be a parameter to the jump command. If I asked you to microwave my pie, you would say for how long. So cooking time would be a parameter for microwaving the pie. So if we go back to our square, okay, we've got our square. When green flag clicked, we set our pen size, pen color, put the pen down clear, call our square block. Here's our square defined, which is a simple repeat with our move and our turn. Now, so if you just go file new, we can go and create that quickly. Go and save. flag clicked. Let's see what we've got here. Pen size, color, pen down, clear. Pen size. Set pen size. Set pen color. We're going to clear and we're going to put our pen down. What values did we have here? 1 and 120. 1 and 120. And we are going to create a new block called DrawSquare. And we are going to define that as repeat for move 100 to 90. So repeat for move 10, move 100, and repeat 90, so turn 90. Okay, and if we run our program, it doesn't work because I didn't add that in. Okay, so you got that, yours working as well. There we go, excellent. Alright, now we want to change the sides, how big we want to make the sides. So we can go to our edit block, edit our square. So if you right click on DrawSquare and go to edit, and then as you saw we've got our options, we can expand. Now we can add parameters. Okay, there are 3 kinds of parameters and one assistant to that. The first one is adding a number input, so length, size, weight, that kind of stuff. The second one is adding a string. Have I been through what strings are before? Okay, string is a string of characters. Okay, so when it comes to data in programming, you have what we call data types. Data types are Boolean, so yes, no, true, false, 1, 0. They are numbers, which can be subdivided into integers or decimals, and they are strings. Okay, a string is a string of characters or letters. So hello, help, this is a wonderful sentence, those are all strings. Even if it's just a single character, we still call it a string. Okay, so we have a number input, a string input, and a Boolean type. You'll see they've got different shapes. The number is a rectangle with rounded ends. A string is a rectangle with square ends or straight ends. A Boolean is a sort of squashed hexagon. And then the last one we've got here is text, okay, or label. And that is if we want to label our parameters. And we'll see how that's going to work in a second. So we're going to add a number parameter, okay, and we are going to call it side. So we click on the first one, we type it in, okay, and side is the name of our parameter. Then we are going to add a label in afterwards, and we're going to call that steps. So the label just helps you know what your parameter is. So we'll call that steps, and then we'll click OK. Alright, now you'll see 2 things. On your define, it has added a side and steps. Did I do that right? I don't think I did. Okay, steps should be text, sorry. Steps. Okay, there we go, that looks right. So you'll see your parameter is sort of like a bluey color on a purple background. The steps being a label doesn't do anything, it's just there to describe the parameter a bit better. And then you'll see in your DrawSquare, where you called it in the on green flag clicked, it has now got a little bubble where you can type in a value. So we can say we want to draw a square of 50, and in order to use that we need to take our side and we need to drag it into the steps block. Alright, so what we do, we call this passing a parameter. So we pass the value 50 into our DrawSquare, which it comes through as a side, and then we use the side inside the code. So if we run our program now, you'll see that our square is a bit smaller. Okay, if we wanted to make a bigger square, we could type in a different value. Okay, run our program and the square is bigger. Okay, now this might seem a little bit silly because we could have just changed the value inside the define block, but the fact that we can pass parameters from one section of the code to another is what's the really important thing here. And we are in a later lesson going to cover a thing called variables, where we store values, and then it's going to become even more powerful. Okay, so that's how we upgraded our DrawSquare or our square block to allow it to use a parameter. Okay, now there are important notes. Okay, the first one is your custom block can only be used in the sprite that you define it. So you can't use it in different sprites because they don't know of the custom block. There is a trick, however, that you could get the one sprite to use another sprite's custom block. Can you think of how we might do that? Yeah, you could do that. You could do that. And if you didn't want to have a copy of the code because of potential problems that might cause, what did we start the lesson off with? Broadcast. So Sprite 1 could broadcast to Sprite 2 and say use your block. Okay. Then, how do we delete a custom block? Okay. If we wanted to do it the normal way, okay, and we say we want to get rid of our definition, it's going to moan. Okay. It says to delete a block's definition, first remove uses of the block. Okay, so our use is over here. So we get rid of that, and then we can go and delete our block. Alright. Okay, and the same goes if you wanted to delete it from the palette. If you wanted to go, whoops, it doesn't even have a delete option. So you have to use the drag option, and you have to make sure you get rid of all uses before you delete it. Okay, then to delete a parameter or a label, okay, if we go into our custom block and we have a parameter 1, parameter 2, parameter 3 and a label, all you need to do is click on it and click on the little black circle with the white crossing to get rid of it. Okay, that's how you delete them. Alright, any questions about custom blocks? No. Okay, so nesting. Okay, this is an example of why it's nice to reuse code. So we've got a custom block called squares, which calls the custom block square. And in each instance we are passing in a different value to get it to draw a different size square. Okay, so instead of having 5 lines for each of these, and there's 4 of them, so we have 20 lines, we have 5 lines plus 1 times 4 lines for each of the squares. So we save a lot on writing of our code. We've also broken it down into smaller pieces so it's easier to debug. Alrighty, so we're going to do a program now called rotated squares, and I'm going to leave it up to you to type it away. Okay. I'll just go through what it does. You'll see the blue arrows here show the sequence that the program is going to run in. We start off with a when green flag clicked. Then we set go to x0, y0 and point in direction 90. Why do we bother having those two there? Exactly. So every time we start the program, it's going to start in the middle and point in a given direction. Okay, as I said before, this kind of code at the top here is what we would call initialization code. And if we wanted to, we could break it out into its own custom block. Then we're going to set our pen size to 1, set our pen color to 120, put our pen down, clear the stage, and then we are going to call rotated squares. And here you can see I've put a red block around it. is defining how many rotated squares we have. So in the bottom right hand side you can see examples. We've got rotated squares 4, rotated squares 5, and rotated squares, this is actually 8, not 6. There's a bit of a typo there. So that's what it should look like if you do 4, 5, and 8. Then our rotated squares block has an input or parameter of count, and we repeat count times because that's how many sets of squares we want. And in each repeat we call our squares, okay, the squares plural, not the square singular, and we turn 360 divided by count. Why do you think we turn 360 divided by count?
Because then it's going to be one complete.
Circle. Okay, so in the case of count 4 we're going to rotate 90 degrees every time. In the case of count 5 it's going to be 360 divided by 5, which is some number I can't work out at the moment. Alright, in the case of count 8, okay, you'll be rotating 45 degrees every time. Okay, in our squares block, it's a simple calling our square block 4 times with different sizes. Okay, so let's see how you're doing. Any tissues? Okay. Do you like something to drink? Okay. Okay, so you've got your initialize there, you've got your rotated squares, you've got your squares and your square. Okay, that is looking good. Okay, that looks good. And what's not working? Because you've got all the code there, but you're not calling it. Okay. Let's pick a value because one isn't going to be that exciting. good. Okay, so now you can see just by changing one value, you can get it to draw something that's quite a lot different. Okay, cool. Does that make sense?
Yeah.
Any questions?
Mm.
Nope. Okay. Alright, this is on your flash drive if you want to have a look at it at home. It's called rotatedSquares.sp2. Alright, now we are going to get into the nitty gritty, okay, of designing programs. There are two ways of designing them. The first one we're going to cover is top down. So you start at the top, break it up into smaller and smaller pieces until you can't make it any smaller, and that's the way you write your program. The second one is where you start at the bottom and go in the reverse order. They kind of seem like the same thing, just coming in it from different angles. So maybe the distinction isn't that important. The important thing is that you are breaking things up into smaller pieces so they're easier to code and you can reuse them. Alright, the first thing you need to do before you do anything though is to understand the problem. Okay, in formal computer programming, you ideally sit down with your customers or your users and you sketch out what they call use cases. So you say, okay, you want to bill a customer. Okay, what do we need to bill a customer? Okay, we need to create an order. Great. Okay, what's going to be on the order? Does it have an order number? What length is the order number? Does it need a date? You know, what are your product codes? How do they look? Do you want to include that, not include that? Is there need to be a logo? Will it look the same for all your customers? Maybe your customers overseas have to have a different order, that kind of stuff. So there's a lot of questions you need to ask in the beginning to figure out what you need to do. Okay, there is no one size fits all. Okay, it's like anything. If you want to become an engineer or a doctor or a builder, experience is the key. Okay, to get experience you have to do stuff. So that's why I recommend you do exercises at home. There are a lot of exercises on the flash drive that you can have a look at as working examples, but I would also encourage you to create your own projects, okay, like you did this week, which is very good. But the more you play, the more you'll figure stuff out. Because I can go through all the theory in the world, but until you actually start using the theory, it's not going to click. Alright, so we are going to build a house using a top-down method. Okay, so let's understand our problem. We have got a house and it's got a couple of components. We've got a roof, we've got the walls, we've got a door, and we've got a window. Okay, now what we can say is for each of these components we're going to create a custom block, and so we've got a draw roof block, a draw door block, a draw walls block, and a draw windows block. Now why do you think I put these question mark by draw window and draw walls? Are they similar in any way?
Yeah, they are.
How are they similar?
Their shape.
They're both squares. The one is just a smaller one and the other one's a bigger one. So we'll see when we get to that how we can make things a bit simpler there for ourselves. Then as I've mentioned before, we've got an initialize at the top, okay, and then we're going to call our draw house, which is going to call all of these in turn. Now in our initialize we've created a custom block where we hide our sprite because we don't want to see it while we're drawing. We clear our stage, we bring our pen up, set our pen size and set our pen color. As before, we bring our pen up because we don't want to see it drawing lines between all the shapes. Okay, now I've got two parameters on each of the house components here. Why do you think is that? Start X and start Y. Why do you think we have
So
that?
the house stays together.
Right, okay, so we are going to be drawing our shapes, but unless we tell them where they need to be drawn, they're all going to be on top of each other. So we need to find out the start position for our walls, for our door, for our window and for our roof. Okay, so this is going to be an exercise you're going to type out. So file new, and you can start creating these. We will go through each of the individual custom blocks, but for now you can just create the definitions of them and do the when green flag clicked and the initialize part. Yeah, some of the pen blocks are tricky because you can't easily see the difference between the set and the change. You see that? Okay. Okay, the draw house you'll only do later, so you'll leave the definition in there. Okay, you also need to create a draw roof, draw door, draw window, and draw walls. Each of them have got a start x colon as a label, and then x as a parameter, start y colon as a label, and y as a parameter. Okay, you just need to name your parameters x and y there, otherwise they're going to be called number 1 and number 2. There you go. No, start x colon. This might be a bit tedious, but once you've got the definitions in place, the rest of the code's a bit more interesting. Fortunately, the conventional programming language, it's all text, so you could do a lot of copy and paste. Okay, you've got all your custom blocks there. Oops. Okay, the auto layout doesn't always work. Alright, so now we get into the nitty-gritty of actually going and defining them. So the first one we're going to do is our door, which is basically a rectangle of a fixed size. And we use our x and y parameters to set where it must start drawing. Okay, why are we only looping twice if it's got 4 sides?
Because it's different lengths.
Yes, so only 2 sides have the same length. So we draw one of each length, side length, and then we double that. Okay, so you got your door. Let's do our roof. You can actually just copy the code from your door and then just change some parameters. Okay, that was easy enough. And then if we do our door and wall, window and walls, we're actually going to create a square block. And we are going to use that to draw our walls and window. So it has one extra parameter, which is the size, because we need to send through a smaller size for the window and a bigger size for the walls. So this is where we get to reuse our code. We use the square for both wall and window. Okay, so now we are going to use our DrawSquare to draw our walls and our window. Okay, I think we've done all our blocks, so now we need to define our draw house block, or put our draw house block together. Okay, once again we have got a pen up in between each call because we don't want lines to be drawn between the different shapes that we're going to draw. In the top right hand corner I've included the magic numbers to make sure your house fits together the right way.
Chances are it's not all going to be right.
Well, let's see. If it's not, you'll have a good excuse to practice your debugging skills. Okay. We spoke earlier about sequence and sequence being important. Is it important which sequence we call our different blocks under the draw house one?
Not really, unless you wanted to draw in a certain
Mm-hmm.
sequence.
So why is it not really important?
Because it's going to give the same end product.
Yeah, so they're independent from one another. So whether you draw the wall or the house or the door or the window first doesn't really matter as long as you get all the elements there at the end of the day. Obviously, if you're building a real house, that wouldn't be the case. You would need to definitely have foundations before you built walls, and walls before you had windows, and walls before you had doors and roofs. But in this case, where we're just drawing a picture, it doesn't matter so much. Okay, so let's see if you manage to build a house. Almost. Almost. So your window is floating and your roof is a bit wrong. So let's go have a look at our roof. Okay, I can see a mistake. Yeah. So most of the time we go clockwise, but every now and then we go counterclockwise. Okay, and let's see your window. Your window.
I think that's the position it is.
Yeah, let's see. Window should be 20 and minus 60. Okay, let's see. Much better. I'd feel much better living in that house. Okay, so did you understand how we looked at our problem, broke it down into pieces? Okay, we broke our walls and our window down into a smaller piece called a DrawSquare because it's a common element. if we get to that, maybe when we do Python or one of the other programming language, that is actually a sort of form of what they call object-oriented programming, where you have classes, and your classes can inherit from stuff. So you would have a square class, and then you would have a walls and window class, and they would inherit from the square class. But that will be a much later lesson. Okay, so we've done the top down. Now we're going to try and do the bottom up. Okay, in this case we're going to start at the bottom with the smallest thing and combine the smaller things going up until we have fixed our problem. Again, we have to understand the problem before we can do anything about it. And in this case we're going to draw this rather complicated looking snowflakey type flower, and we're going to start off with a simple element called the petal or the leaf, I think. So if we look at the different components, we have a leaf, which is a simple two-sided shape. We've got leaves, which is 5 of the leaves, and we've got a branch, which is 1 leaf plus leaves plus a stem, and then we've got the total flower, which is 6 branches. Okay, which one do you think is the most complicated?
The branch.
That one.
Yeah.
Okay, no one ever gets this right.
Did I get it wrong?
Yes. Okay, I'll ask you again when we're done. Alright, so we're going to start off with our leaf, which is the smallest thing, which we draw like this. Okay, so you're going to have to file new. Okay. So we draw our leaf in 2 halves. We draw the top half by moving 15 times, or repeating 15 times. We move 2 steps and turn by 6 degrees. You'll see that 15 times 6 works out to 90. And then after we've done that, we turn another 90. So from moving where the yellow arrow is all the way there and getting ready to do the second half, we've gone through 180. Then we do the same for the bottom side, and by the end of it we've done a full 360 degrees. So we've come back to where we started. Okay, so you've got your leaf, got your directions right. Okay, now that super complicated leaves block. Basically calling our leaf custom block 5 times, and we're rotating by 72 degrees, but 72 times 5 is 360, our favorite number in Scratch. Okay, and we are going to do our branch, which is almost as complicated. Okay, with our branch we are drawing 2 lines. So we move 40 steps, draw a leaf, move 50 steps, draw the leaves, and then we move back minus 90. Why do we move back minus 90? So we go 40, 50, and then we go minus 90. Because we want to get back to where we started. Okay. Alright. We'll explore that a bit more when we're done with our coding. so we've got our branch, and now we're going to do our flower, which is also super complicated. And we are doing 6 times 60, which is 360. Okay, so now we've got all our blocks, we just need to use them. So we do a bit of initialization code under our when green flag clicked. Okay, so okay, I think there's a bit of a problem somewhere. Houston, we have a light bulb or a couple of hands. Okay, let's go back through the code and have a look what went wrong. Okay, is your leaf right? Oh, that looks a bit better. Much better.
It's like, it's amazing how one small little problem can change so much.
Absolutely. So, again, which part was the most complicated one? Yep. So the thing that looked the most simple to do was actually the most complicated one. Okay, so let's do a bit of playing around. This is on your flash drive. It's called Flower Flake. Okay. What would we do? Well, how would we make our leaves a bit bigger?
You can change these steps over here.
Yeah, that's a good start. Okay, bigger leaves. Okay, how would we make more leaves in the flower at the end? Okay, so if we want to make bigger leaves, we increase the step size. Okay, so it makes bigger leaves. If we wanted to make more leaves, we would change in our leaves block. If we wanted to make, say, 8, we would repeat 8 and turn 45 degrees. Okay, that gives us more leaves. Or not. Or not.
Change something here and then show me this number.
Which
Flower.
one? Flower.
I think this number needs to be changed. 8.
Yeah, that needs to be 45. Okay. If we wanted to make our stems a bit bigger, okay, we could go in here and make it 60 and 80, and then remember we have to go back the same amount, so 60 plus 80 is 120, so we go to minus 120.
Oh, this is so cool.
Yeah.
Like this little, okay.
Okay, so I think that ends today's lesson. Hope you enjoyed it. Do you have any
Oh,
questions?
yeah, no.
No. Alright.